When someone is injured in a futuristic sci-fi movie, there are all of these high-tech medical devices and machines helping to rebuild and heal the humans. Whether it's a machine that hovers over them like a scanner, or a robotic arm that's going over a wound and printing new parts. But all of this sci-fi-like tech is being developed today. And this video looks at all of the ways 3D printers are making it happen. There are already 3D bioprinters that use bioinks made from human cells, which means that something biological, such as bones or cartilage, can be printed now. 3D printed titanium is already being used to replace human parts. And next-gen prosthetics can also be hooked up to the internet. What if a prosthetic arm could download a program to play a song on the piano, allowing humans to download new skills? And could we soon be seeing prosthetics that will give humans super strength and speed? As 3D printed parts and robotic prosthetics become more human, and humans become more artificial, will we have to change the definition of what it is to be human? There has been a lot of talk about Elon Musk's brain-to-computer interface company Neuralink because they have been showcasing their latest updates and how they are able to now measure brain activity in pigs. Elon Musk's goal is to solve brain and spinal problems using this brain-to-computer device. Though it seems in the realm of science fiction, this is something that can be done on a DIY and basic level today with the help of a 3D printer. OpenBCI is an open-source brain-to-computer interface that anyone can 3D print and build at home. The structure is 3D printed and electronics are then fitted. This kind of EEG headset can measure basic things like concentration, attention, along with eye and facial movements. And people who are willing to invest the time are able to build one that can control robotics and prosthetics using their thoughts alone. Prosthetics is one of the more common areas when it comes to 3D printing human parts, but today they are getting more advanced and high-tech. Open Bionics creates prosthetics using 3D printing. The Hero arm is an arm that responds to the user's muscles. Using electrodes placed on the skin, it can detect the voltage generated when someone flexes their muscles. This allows somebody to control the movements of their robotic arm. And since it is 3D printed, it makes it simpler to create different designs, and children can get new arms printed as they grow. Ubionic also 3D prints prosthetic arms similar to Open Bionics, but they also 3D print augmented arms. The company sells the materials and instructions for a user to 3D print and build their own robotic limbs and human extensions, adding to the ways humans can control robots. The company is developing more advanced ways of controlling the devices, such as using the electrical activities from the brain. There are 3D printed arms that are open source and made available by eNables. This means that anyone across the world is able to take the measurements of a child's arm, plug the measurements into a computer, and it will adjust the size of the 3D model, making it ready to print. Volunteers are based in over 100 countries, ready to work on 3D printing and assembling the 3D printed arms. The eNables arms are designed for people who have a working elbow or wrist. This allows them to control the arm by bending their elbow or wrist, making the 3D printed hand open and close. Hands are a main focus within prosthetic development because a working hand allows people to do essential tasks. A child that is missing both hands is unable to feed themselves, but by having a 3D printed hand that they can open and close by bending their elbow lets them use a spoon to feed themselves for the first time. Naked Prosthetics has created finger prosthetics called the MCP Driver that are made of 3D printed stainless steel and a nylon polymer. The prosthetics can be customized, such as adjusting the number of fingers that need to be added. What about connecting 3D printed human parts to the internet to make them smarter? An Italian startup called Rejoint is building 3D printed cobalt and chrome knee replacements. Sensor-equipped headbands and socks measure how the user is loading and bending their knees. The data is sent to their surgeon, who can help improve the performance of the 3D printed knee replacement. Could we soon see prosthetics that allow humans to upgrade themselves to be better than before? We have already seen that with 3D printing and advanced materials, 3D printed parts for humans are starting to reach natural levels of performance. Soon, these printed parts will exceed the capabilities of natural ones, and next-gen prosthetics will give humans increased strength and speed, all without the risks that come with natural parts, risks such as cancers or injuries. What about adding other sensors to the prosthetics that can communicate with the internet? Could prosthetics download new music to play on the piano, or be programmed to build things, allowing humans to download new skills? In the not-too-distant future, we may see people volunteering to have their limbs amputated or organs replaced with longer-lasting, more advanced versions, letting humans upgrade themselves with different parts. Titanium alloys are being used when it comes to replacing or fixing human parts because they have a porous, bone-like structure. This leads to the artificial titanium bone acting much more like a natural bone, which may never need replacing. There are already 3D printed titanium implants for spinal conditions, helping prevent paralysis. This can be seen from a company named Emerging Implant Technologies. Another way titanium is being used is in bone implants. Traditional bone implants, including knee and hip replacements, last for about 15 years before requiring a replacement. This is because of the screws and adhesives, along with the unnatural materials that are being used. Patients around the world are just starting to get access to titanium 3D printed rib cages. If a patient has a tumor in the chest wall, it could be required that the chest wall and/or ribs be removed, leaving the vital organs unprotected. The 3D printed titanium sternum and rib implants then protect the vital organs again. The replacements are made up of a mixture of titanium and a polymer. Polymer materials are commonly in the form of plastics, and in this case, the polymer part of the implant provides flexibility while the titanium gives the strength. 3D printed titanium is also being used to heal humans through the use of a titanium cage. In the UK, patients now have access to a 3D printed titanium cage for severe shin fractures. Previously, severe shin fractures required amputation. But now, a custom-made 3D printed titanium cage is implanted to squeeze all of the bone fragments back together inside of the leg. This encourages the bone to fuse together and avoids the need for amputation. The titanium cage is then kept in the body for added support. Titanium does not always have to be used to create next-gen human healing parts. It is not needed when it comes to 3D printing casts. 3D printing a cast for a broken limb allows for the bone to heal in an efficient, water-resistant, and high-tech way. These casts can be built with a rehabilitation module that stimulates the muscles with electrical signals. This way the muscles don't get weak while the bone is healing in the cast. The cast can be controlled with an app and also allows doctors to monitor the progress and manage the treatment. Exovite has advertised that rehabilitation time for an injury similar to a broken arm, hand, or foot could be cut to 7 weeks, down from the 10 weeks it takes with a traditional cast. 3D printers that print biological parts are called bioprinters. Biofabrication is another name for bioprinting. Printers traditionally used for automobile design and prototyping have been adapted for bioprinting. These printers use cells and other substances to 3D print tissues and other structures. Some of the newest bioprinters have 6 print heads so that 6 different cell types can be printed to create a complex tissue model, such as intestinal tissue. So what can these high-tech 3D bioprinters print? Scientists can 3D print structures that mimic tissues and organs which are used during clinical trials, reducing the need for using animals. Bioprinting can also be used for tissue repair. When it comes to bone tissue, bioprinters can be used for a lot of dental and jawbone reconstruction. Over 2 million people worldwide need bone grafts every day. At Swansea University, printed bones can be made in a couple of hours. They are transplanted into a patient and fuses with the natural bone over a period of months. Even eyesight can be fixed with 3D bioprinters. Millions of people worldwide need cornea transplants, which is the lens that covers the eye and focuses vision. And Newcastle University has used stem cells to create a bio-ink that allows the scientists to 3D print circles to form a cornea in under 10 minutes. Wake Forest School of Medicine has successfully printed skin cells onto a burn wound. Ears and nose replacements can be printed for accident victims. Scientists in Zurich are able to print a nose in less than 20 minutes. At Wake Forest University, a bladder has been printed from a patient's own cells. Because these organs are grown from the patient's own cells, it takes away the risk that the organ is rejected by the body. Liver patches are being printed to help patients until they can get a full liver transplant. Scientists have also successfully 3D bioprinted a thyroid gland as well as a patch of heart cells that actually beat. More complex organs like livers and kidneys are about 10 years away. And what does the future hold for our brains? Could we ever print a human brain? Researchers from Tsinghua University have 3D bioprinted brain-like tissue structures with neural cells that formed their own complex neural circuit that responded to external stimuli, meaning it could respond to something such as music. Think of it as a brain in a petri dish. While normal printers use ink and everyday 3D printers use plastic, 3D bioprinters use bioinks. A bioink is made of living cells. These cells might come from the patient or from cell donors. Bioinks can be natural or synthetic. Kevlar is an example of a synthetic bioink, and bioinks can also be extracted from seaweed. Different bioinks can be used for different parts of the body. There are bioinks that help with growing cartilage, bone growth, liver growth, muscle fiber growth, arteries, bladders, intestines, skin, lungs, and much more. There is even a bioink being developed that can be conductive, like a nerve cell conducting an electrical signal. This means that one day it will be possible to 3D print completely functional biological parts that require electrical signals to function, like muscles. And lastly, there is Marie, the first life-sized 3D printed human body developed at LSU. She was 3D printed using bioplastic, which is a mixture of plant-based materials such as wood chips or plant waste. Marie was printed to test real-time radiation exposure to help scientists optimize radiation dosing for cancer treatments. Marie is 5 foot 1 inch tall and weighs 15 pounds. She has a 36-gallon water storage capacity to mimic different body types. She gets filled up with water, and the scientists see how much radiation penetrates to determine the effect radiation might have on real tissues in cancer patients. Moving forward into the future, there will be nanofabricators that will allow us to 3D print anything, well beyond what we can manufacture today. James Burke, a British science historian, predicts that nanofabricators will be common by 2042. Such a device would mechanically or chemically combine molecules, allowing us to turn raw materials into any end product. On the next episode of Venture City, we take a look at the self-driving city of the future and the ways it will change how we live, from the roads we walk on to how we build our homes. Hit the subscribe and thumbs up button to not miss a video.